In this video, I'll explain why the poisson, random variable, and the exponential and the gamma can all be explained everything with pizza store. Make everything very, very simple. Everything starts off with a pizza store. How so? We start off, there's a certain pizza store that has taken some track that they have 10 customers per hour. Average, they did it for a long time, came to the conclusion that they have an average 10 customers per hour. Now, let's see how many different ways we can tweak and twist this question, and everything is going to turn out to be a different version of the same idea, just in different expressions. So let's start like this. The first question we may ask is, if we have 10 customers per hour, how long does it take for the first customer to come? How much time does it take for the first customer to show up? So you say 10 customers per hour, so it's probably 1/10 of an hour. Yeah, that's good. But we need to know the probability. How about the first customer? It will take it can take more, it can take less. So we start off with a exponential distribution that teaches us like this. If you have 10 customers per hour, let's remember, when we're dealing with exponential distribution, we're dealing with time per customer. How many time it takes. The unit of time here is an hour. If it's 10 customers per hour, it means that six minutes for the first customer to come. I don't want to use minutes. 1/10 of an hour. So let's use just hour. I don't want to get confused. Let's use the term of hour. So 10 customers per hour means the first customer is 1/10 of an hour. Remember, we're focusing now on the first occurrence. How long does it take? How much time does it take for the first occurrence? Here the occurrence is the customers and the time is an hour. So if we start off with this assumption, 10 customers per hour, it means that one customer is 1/10 of an hour. So the first occurrence, fancy word, that means customer, both have a C. The first occurrence is 1/10 of an hour. So we got to know this magic thing here, 1/10. That is right now the average amount of time it takes for the first occurrence. The reciprocal of that will be the gamma parameter. So in this case, the reciprocal of 1/10 is 10. So I'll write down on a page, write down the CDF of this exponential distribution, and then I'll explain you what it is. the PDF of this is 10e negative 10x. Why 10? Because we always remember we do the reciprocal to get the gamma parameter. So if we started off at the expected time for the first guy to come to the pizza store is a tenth. Remember here we're using here units of an hour. So the first occurrence is a tenth. Reciprocal of a tenth is 10. So this will be the PDF. The CDF, you all know, is just simply 1 minus e negative 10x. So to get this down into a very practical equation, somebody might ask, what's the probability that the first customer should arrive in, should take him at least this first customer should arrive before half hour passed. I go into the store, open up the shop. What's the probability that the first customer should arrive before a half hour elapsed? Probably it's very high probability, so let's do it. The way to do it is you just take in this x, you plug in the x a half. So it's 1 minus e negative 10 a half. That's negative 10 is negative 5. 1 minus e negative 5. I'll use a calculator for that. One minus e negative 5 is 99%. 99% that there should be already somebody here in the store after a half hour of waiting. And so on. X can be any time that you plug in. It can be a half hour, it can be a quarter of an hour. Let's say that can be a more legitimate question. What's the probability we should have a customer before a quarter of an hour? So you plug in X, you plug in a quarter. So if you do that, you get 10 times a quarter is 10 quarters, that's 5 halves, that's 2 and a half. That's 1 minus e negative 2 and a half. 1 minus e negative 2 and a half. 91%. Also very likely that somebody should be here in a quarter of an hour. So we got the picture here, obviously. Okay, now we go to the next part. So here we got the question answered, all the different probabilities when the first occurrence and the first customer will walk into the store. I just opened up the store and I'm waiting and sitting on my chair for the first customer to appear. And I'd like to know all the different probabilities. I will just give you x will be the time, and you tell me what the probability that it should take x amount of time for the first customer to come. Next, now we go different question. The same pizza store, the same rules. 10 people come in per hour averagely. Next question asked is, what is the probability that we should have 9 customers, exactly 9 customers per hour? We know that's normal, the average, but it doesn't have to be that way, right? Well, the probability should only have 5 customers. I'm opening the store and I'm starting to count. What is the probability that now it's 9 o'clock in the morning, from 9 to 10, should only have 5 customers walking in? Or maybe 0 customers, God forbid. What's the probability that should happen? Here comes the Poisson distribution. that teaches us, I'll give you a new page for that. Again, in this case the gamma would be here 10, because why is gamma 10? Because we're telling you that 10 customers per hour. It should be noted that before we created the gamma as 10 because the 10th was the time, 10th of an hour for the first customer to come, and we converted that into 10. By poisson we simply don't need to convert, we just use very straightforward language. We say since there are 10 customers, so we just use gamma as 10. Very, very straightforward. Now, let us write down the Poisson distribution. It goes like this. And we'll only put in the PDF because it's easier. Sorry for that. Okay, take a look on top of the page. E negative gamma x over x factorial. X stands for how many people? So we want to know the probability in the next hour it should be exactly 5 people. You just put in E negative 10 gamma 5 over 5 factorial. This is the probability this is the probability. Look on the bottom, E negative 10 gamma 5 factorial. Probability of having exactly 5 people coming in this hour. How about probability of having 0 people coming? Exactly 0 people. So just fill it out. Gamma is 0, so I'm sorry, gamma to the 0th power is 1. If you just put in the wherever it says 5, you put in 0, it ends up being e to the negative 10. So that's e to the negative 10. We should have 0 people. Hello. So this is the probability of having 0 people. As you see, you just put in, wherever it says 5, put in a 0. So you get e to the negative 10. E to the negative 10 to have 0 people coming in the first hour. Obviously, because to have a why is this true? If this matches up what we said before. It is 1 minus e to the negative 10x to have a person coming in before the first hour. So obviously nobody coming in, 0 people, is e to the negative 10. What's going to happen afterwards, nobody knows, but that's for sure that right now nobody's coming in. That's e to the negative 10. That's the second half of 1 minus e to the negative 10. So to sum it up, we just went through now the poisson and the exponential. By the exponential distribution, the x value stands for the time. So the question is always asked how much time it takes for the first guy to come. And then you have to tell me all kinds of probabilities. What the probability should take 1 hour, a half hour, a tenth of an hour. So you just have to fill in the CDF, in the x stands for the hours, how long it takes for the first person to come. In the poisson, the question is asked, the x represents the people, not the hours. How many people will come in the first hour? 5 people, 6 people, 7 people. X is for the people. Now we get to the third thing that's related to this whole topic. That is the gamma distribution. The gamma distribution is telling us like this. I would like to know time, but not how much time it takes for one person, how much time it takes for many people. How much time do I need to to have 3 people coming in. Actually, the third person should walk in. How much time do I need? 4 people. We know already how much time you need for 1 person. That's the simple exponential distribution. However, how much time do I need for 3 people? So obviously, if for 1 person to come in you need a tenth of an hour, so you can say that how much time is necessary for 10 people okay, so here the probability is asked like this. X is going to represent the time again, not the number of people. X represents the time. Very important. What's the probability that in X amount of time you should have a certain stationary number of people? So let me explain you the question. X is going to be fluctuating. X will be the random variable. What's the probability that it will take a half hour to have 3 people? What's the probability it's going to take 3/4 of an hour to have 3 people? What's the probability it's going to take 1 hour to have 3 people? What's the probability it's going to take a tenth of an hour to have 3 people? What's the probability it's going to take 2 hours to have 3 people? So you have to decide on a certain number of people. Let's say 3. We're interested in 3 people. And then the X will be the amount of time it takes to have 3 people. So how do we calculate that? Let's make an example. How do we calculate? What's the probability that it will take it will take 20 minutes to have 3 people? Now let's explain something. When we say, sorry, I shouldn't have said 20 minutes, a third of an hour to have 3 people. Now when I say a third of an hour to have 3, what do these words mean, to have 3 people? It means that either the 3 people come here before a third of an hour, or they at least by a third of an hour we have already 3 people. So we have 4 people at a third of an hour. I'm definitely happy. I just want that by a third of an hour we should be having already 3 people. So let's say if by a third of an hour I have 4 people, I'm definitely happy. 5, I just do not like if by a third of an hour I only have 2 people. I'll get very upset. Anything more than 3 people is good. Just like when we said we want to have in a certain amount of time the first occurrence. If you have 2 occurrences or 3 occurrences, definitely that's okay with us. Means at least by a certain amount of time that occurrence should happen. Let's say we say the first occurrence by exponential distribution before, should have a customer arriving before a tenth of an hour. If 5 customers arrive before a tenth of an hour, That's definitely good. That's also part of the probability. Only thing that's not included is if nobody arrives. That can also be. That's not outside of the probability. Anything between one person and infinite people arriving in X amount of time, that is what we're seeking for, and that's a probability that we're asking. The same idea is here, same logic when you're talking about the gamma distribution. You're asking probability that in a third of an hour you will have at least 3 people. 3, 4, 5, 6, 7, 8, 9. So it's quite simple. It's everything and anything beside the possibility that in a third of an hour you will only have 0 people, 1 or 2. So basically 1 minus the Poisson distribution of e to the negative 10 gamma to the 0, e to the negative 10 gamma to the 1, and e to the negative 10 gamma to the 2. All these possibilities I do not like. It's everything besides these 3 cases that I am upset with. Of only having 0 people,